Now we're going to talk about IDR. Now I mentioned IDR in the previous tutorial for the L2 because it's an integral part of that plugin, and it's also an integral part of most of the other L-series plugins and all the L-series limiters that we're going to be talking about in future tutorials. But it's such a complicated topic that it does deserve a movie unto itself. Now, IDR is an anagram for increased digital resolution and is simply Wave's term for dithering and noise shaping, the two processes inside the requantizing module. Now, by requantizing, we're talking about when we lower the bit depth of a file. And this process should be applied every time you lower the bit depth of your file. And that's generally going to be the case when you're outputting a 16-bit file for CD or video or whatever your final application is. Because do understand that we're working in a 24 or greater bit domain. And that applies even if you've got a 16-bit session. So say here in Pro Tools, it might be a 16-bit session. You might have brought in files from an existing CD, for instance, into a 16-bit session. But all the processing you're doing within here is occurring at a greater resolution than 16 bits. So in my case, Pro Tools HD, the calculations are 48-bit. The plugins are talking to each other at a 24-bit resolution. So even though I might be working on 16-bit material, I am now up at a higher resolution as I work, which means that when I finally output that session, I have to dither as I bounce down to 16-bit resolution. Now the reason I've got the L1 over here open is because that's going to allow us to demonstrate the powers of dithering better than any other plugin we've got. And that's because the L1 allows us to dither right down to 8 bits. Now back in the early 90s and the mid 90s when the L1 was at its peak, this was useful for times when you're outputting audio for video games or the internet at the time. Now these days, of course, there's literally no need for 8-bit audio. Everything on the internet's going to be 16-bit audio. Anything for video games and so on is also going to be 16 or greater bit resolution. But this 8-bit on the L1 is a great way for us to demonstrate exactly what's going on. So here's what we're going to do. In order to exaggerate this to show you exactly how it's working, I've had to do some pretty crazy stuff. Now, first of all, I've got an SSL plugin here that I'm using purely just as an attenuator. I've got its input here down about 13.5 dB. So it's reducing by 13.5 dB, and that's all it's doing. Everything else is flat. So I'm just using it as a gain reduction device. That's feeding off into this L1, and this is all going to sound pretty crazy, but just follow me for a second. The L1's got its out ceiling right down at -30. So in other words, whatever the L1's doing, I'm now saying to it, now spit it all out 30 decibels softer. And I've got about 10 dB of threshold here, so I'm turning it up by 10 dB and then turning it all down here by 30 dB. Now that hopefully will become clear in a minute what's going on there. And then following this plugin, we're going into an L2, which is just making up the gain 21 dB. So really what I'm trying to do here is make the actual signal from this file here fairly soft, but bring up all the noise at the same time so we can hear the effects of requantization and then hopefully the dithering on top of it. Now, don't worry about what this fella's doing here. That's just making up gain. So really all the money is inside this one. Now at the moment it's set to a 16-bit requantize, so you're not going to hear any degradation at that level. I'll just play a little bit here and you'll see. So there's our song, everything's getting through, and that's not a problem. But what I'm going to do now is get this L1 here to requantize that audio to 8-bit. And in fact, I'll make it even nastier by using the front of the song, which has got a soft intro, and you'll hear the sort of damage I'm talking about. Now the dithering is off, the noise shaping is off. Now listen to what happens as I switch down from 12-bit and then to 8-bit. Bit of hiss now. Right. Ugly. Now the issue here is that not only does it sound disgusting and horrible and crunchy, but actually parts of the audio are literally falling off the cliff, so to speak. We're actually losing bits of the song. It's falling over. They're actually getting lopped off as the signal is getting truncated. And that's exactly what's happening. 16 bits of audio out of our 24 that we're passing through are getting thrown away, just sliced off at the knees, and we're only left with the top 8 bits. But the top 8 bits have been reduced in volume so much that there's not much there. A lot of it's falling underneath. And so it's actually getting thrown away. So dithering and noise shaping now are psychoacoustic kind of tricks that are trying to fool our brains into thinking that the audio is not as bad as it is, because natively you've just heard what's really going on. These processes are ways of tricking our auditory systems into thinking that things aren't as bad as they really are, and it's actually quite an amazing process. So this dithering here comes in two sorts in the IDR module, what they've called type 1 and type 2. Now if I hit type 1, And there's type 2, which is virtually invisible at the moment. Now, you're hearing that as a massive burst of noise, obviously, but listen very carefully to what that burst of noise does to this audio. So there's our audio virtually disappearing. Now listen. Now listen to the music underneath. I'll just shut up for a minute. So suddenly, turn that off again, sorry. So suddenly the audio is not cut off and choppy, it's actually there. It sounds like it's all buried underneath this horrible hiss, but it's there, it's audible. So that in itself is an amazing thing. So the dithering itself is an injection of noise which covers up all the junk at the bottom end of the spectrum, which is ugly and horrible, and replaces it with the noise, which to our ears is much more acceptable. Now in this case, as we've said, it's incredibly exaggerated, so it's not acceptable at all. But when we're dealing in a 16-bit domain, when this stuff is like 90 dB below zero, it's much more acceptable to our ears and much smoother. So that's the dithering. The noise shaping is a secondary process on top of that, where that dither is kind of moved out of that horrible harsh area that we're hearing it in now and is moved into an area in which the human ear is much less sensitive. So at the moment it's kind of in that 1K to 6K area where the human ear hears it the loudest and it's the most in your face. But then if you apply noise shaping on top of that, it moves it up to an area which the human ear is not as sensitive. So let's have another listen to this. So there it is, virtually inaudible. Okay, type 1 dither. And listen to what happens when I hit the noise shaping. Okay, now moderate is all we're going to get. If we go beyond that, we lose the audio altogether because we've run out of bits in this case. But I'll go back to moderate again. Okay, so there's the none. And that's the beginning of it. Now that hiss is a bit higher and hissier. You can hear it like a bit more grating, even higher. Turn that off. Just bypass for now. But you can hear that the frequency of the hiss is getting moved up the spectrum. And if we were operating at more conventional levels, it makes the whole dither thing more invisible. Now you can apply the noise shaping, but not the dithering. So let's have a look at that. I'll turn the dithering off and the noise shaping's already off. Okay, now I'll play again. Okay, so here we go. Now even that has made it much more audible. You can still hear it kind of falling off the cliff in the softest parts there. Like at the very, very beginning it'll be even more obvious. So we're still getting some ugly artifacting, but it's not as bad as with this off. Here we go, none. Now I'll stick it in again. So normal noise shaping there. Makes it much nicer. And then if I put dithering on, we'll lose that. I'll go back to the moderate. Now type 1. So in spite of the fact that that noise is very, very loud, it does sound like we're hearing the whole program underneath, even when I come back here. So you need keen ears, but it does sound like the entire program is unaffected there. So as a demonstration, I think that shows the effects of dither and how it can remarkably take audio that is quite damaged and give the impression that it's actually not so damaged by replacing it with low-level noise, which of course is high-level noise right now, but in the real world is low-level noise. So it's a very, very important system, and you do need to apply this every time you requantize the audio. Now, the golden rule with all this sort of stuff is you apply this at the very, very end of your chain, just like you would with your limiter, which is the obvious reason why the requantizing module is built into the limiter, because the limiter is designed to be that final stage in your process. Now, in terms of all the choices here, ordinarily we would be on 16-bit, and we've got two sorts of dither, as we said, type 1 and type 2. Now they differ in the recommended ways in which you should use them. As a conventional best use, type 1 normal is a standard kind of setting that you would normally want to use. And type 1 normal is great because if the file that you're working on does need to have further work after that, it's not going to be so destructive. It's totally doable. For the highest quality output at the lowest perceived noise, type 1 Ultra is recommended, but it's absolutely not recommended if that file is going to see any more changing in the future. So it's really only recommended if that's the end of the line for this file, like you're outputting it as a final master, it's going to go off to CD replication or whatever after that. So type 1 Ultra in most cases is the highest quality output. Type 2 over here is recommended as the lowest noise algorithm of the two, but it's not just as simple as using that one all the time because it's the lowest noise. So I'd recommend you look at the manual for this because there's a number of combinations that are available between these two settings, type 1 whatever, type 2 whatever, and then there's 4 versions of noise shaping as well. Now I won't go over them all now and say this one's good for this one's good for that any further than I have, but there's all sorts of combinations here that do differ in subtle ways depending on what your intended use of the file is and depending on kind of the content of the file itself. So I recommend you read the manual for that. But at least now we've had a really decent listen to what requantizing can do with proper dithering and noise shaping algorithms and the benefits that they can bring to your masters. So I hope that's been useful, and I'll see you in the next tutorial when we tackle the L3.